Good evening, everyone, and welcome to my YouTube live discussion. This evening, I'm going to discuss, um, some things that I saw going on as far as people preparing for this corona pandemic that we have going on now. Um, Seeing people go and buy up things like hand sanitizer and, toilet paper and all these things that, really are not going to have an effect on reducing the spread of the virus. So I thought I would do this YouTube live just to explain a few things, especially as it pertains to the hand sanitizer and the antibacterial soap. So I'll start in like 1 minute. I'm going to turn the camera off so that I can focus on just the slides. Can everybody hear me okay? That's in here? I'm doing good, Frank. How are you doing? So this evening we're going to discuss what is biosecurity. We're going to talk about what are microorganisms, and that's going to take us our discussion into what is microbiology and what is the difference between a bacteria and a virus. Then we're going to talk about some antimicrobials and modes to control microbes. Then we're going to conclude, and I'll talk about kiwi produce again. If you all have any questions, you can ask them at the end, but you can also ask them during the presentation as well. So what is biosecurity? Biosecurity has multiple meanings, and it's defined differently according to the industry that is defining that term. The term was first used by agricultural and environmental communities. Starting from the late 1990s, the term was used in response to the threat of bioterrorism. Hey, Midnight Queen. Hey, something by Sophia. So what is biosecurity? So the agricultural definition of it is, on a farm, attention to biosecurity is most important measure to reduce and prevent the introduction of diseases or pests of animals and plants. Biocontainment are practices that minimize the spread of disease pests within a farm system and also prevents them from leaving and spreading to other farms. So like I said, this term usually started on farms and, agricultural operations and things, but it has actually spread out to, now deal with, bioterrorism and things like that. But basically, biosecurity is trying to prevent the spread of disease or pests in a particular area, in this case, on a farm. And if you do have an outbreak, trying to contain that and keep that, pathogen there on your farm, so it doesn't get out into the community and, infect other people's farms as well. So biosecurity measures movement or control or restriction of people, animals, plants, vehicles, and equipment, and waste. You also want to have personal protective equipment, isolation of infected and suspected animals, plants, or people. This is what you call quarantining. And you want to have proper cleaning and disinfection procedures. And you also want to have an integrated pest management. Integrated pest management, it could involve wildlife, things like rodents, birds coming into your farm and things. They can bring diseases in. Rodents can bring diseases in. They can damage things and things like that. Also, arthropods, controlling things like flies, mosquitoes, and things that can bring disease in. You want to have some type of plan to manage those things. So when you're on a farm, a lot of times you'll see signs like, say you visit a farm, there's certain areas you're not allowed to go to. They'll have signs up and things that say like, stop, you can't enter this area. You'll see like what are called foot dips where you actually go and you can put your shoes in there, or you'll have to wear the shoe covers and things if you're going to certain areas. Also cleaning the equipment and things that helps cut down on the spread of disease and things like that, as well as using things like if you're growing crops, you want to cover your crops with like row covers and stuff to prevent insects or things that may come in and actually infest those things as well. I don't know if Kroger's is equipped to help patients with the the coronavirus. I'm not sure. You would have to call them and see if they either have the equipment to do the testing, or they'll probably refer you to a doctor's office or a hospital or a health department. So what is biosecurity? So laboratory biosecurity is a lot different than actual farming biosecurity. This is a protection of control and accountability for valuable biological material, or VBM, in order to prevent their unauthorized access, loss, theft, misuse, um, or intentional release or diversion. What they do is they come up with these protocols to actually keep these bacteria or these viruses and things in the lab, and they're not getting out into the community. So biosecurity and bio safety, they kind of cross when it comes to controlling these VBMs. Um, and there's protocols and things that are put in place. I used to work in research labs, and they had different bio levels of pathogens. Bio level 1 was like things that are not pathogenic. They're normal everyday flora and things like that. As you got up into the levels, I think they go up to bio level 4 now. Bio level 4 would be like a Ebola virus or something that quickly spreads, and there's no like real cure for them. And so you would want to make sure things in bio level 4 do not get out into the environment. So there are a lot of different protocols and things that people have to undergo. If you're working in those they call them BSL-4 labs, you have to do like showering, you have to have a change of clothing, you have to sign in and out. It's a lot of things that they try to prevent the spread of these diseases. So what is a valuable biological material? It's collections and reference strains of cells. So like when they collect, say, a cancer cell or something, and they store it inside of a freezer, those would be cell culture lines. Also, say with some other like the Henrietta Lack story, that would be like a cell line culture. She was a great example of that. The other things that you will find are these valuable biological materials are pathogens and toxins. So, COVID-19, they're probably going to be in a lab somewhere. These viruses, so that would be in a lab. Things like SARS, MERS-CoV, Ebola, hantavirus, all these different things, they have these in labs because they actually do research on them. But there's always that potential that these organisms or these, agents and things can get out and actually make people sick or animals sick or even plants sick. You also have vaccines and other pharmaceutical products. A lot of the times the cures and the preventions for these particular pathogens are also located there in those facilities as well. Things like in a second, the development and production of food products, genetically modified organisms, non-pathogenic microorganisms, and cellular components and genetic elements like DNA, RNA. Like when you have your when you guys go and do those tests for your your heritage and things like that, that would be a biosecurity example of they have to protect that information because a DNA and RNA, that can tell you a lot about a person, as well as they can use that and do things with it. So that would be a place that will have to have biosecurity. For some examples of, I kind of talked about these already, but the different categories of biological pathogens would be like anthrax, botulism, that would be in class A, category A. Category B would be like hepatitis A, West Nile virus. And category C would be like SARS. What we have is COVID-19 right now, Ebola, things like that. So even with top-notch biosecurity, pathogens can still get into the environment either accidentally or intentionally and cause disease. So these are some key words that I keep hearing said in the news, and I wanted to clarify what each one of these was and what they were not. There's different types of outbreaks. Right now, we're in what is called a pandemic, and this is when a disease spreads pretty much across a large region, usually across the world. So when AIDS and HIV was spreading, that was an example of a pandemic. Tuberculosis is another one. The COVID-19 that we're experiencing right now, that is a pandemic. It is spread to almost every continent in the world right now. When it originally started, there were first incidents, which is a number of new cases in a population occurring in a given time period. So when it first started in Wuhan, China, they had incidents. They had an increase of people that were having, this pneumonia. It was, it was killing people. But it were a lot of people that were recovering, but they were all having like these breathing difficulties and things like that. So it went from an incident to being an epidemic when a disease, spreads rapidly in an affected area for many people. So an example of that is like the flu. We have flu epidemics all the time. But what's going to happen with this COVID-19 once pretty much everybody in the world gets it is going to become endemic, which means it'll be a disease that is always present within a population. So you might have, sporadic increase in cases, but it's going to be expected. They'll be able to handle that once pretty much everyone in the world gets it. Mortality, that's another thing. Mortality is a number of individuals that die from a certain disease in a given time period. So our mortality right now for COVID-19, I think worldwide is at 3.8%, and they're just basing that by how many people have had the disease, and then actually giving a number of how many people have died from the disease. Now, there's another term that I didn't put on here. It's called morbidity, and that's the number of people that are actually infected, the collective number of all the people that are affected with the disease. So morbidity is always going to be probably higher than mortality. Those two never are actually, hand in hand even. It's going to be a lot more people that have a disease, but it'll be a lot more people that recover. But mortality is when the people actually succumb to that disease as well. Oh, you're welcome, Lucy. I was speaking a little bit. I'll talk about the difference between the flu and coronavirus at the end. I actually did a whole webinar about the flu and the coronavirus. You can visit my school website if you'd like to purchase that. But I have done a whole presentation about the difference between the two. They're actually two different viruses, two different virus families. All right, so I know y'all have heard about the CDC in the news, but I thought I'd explain what the CDC actually is and what they actually do. So the Center for Disease Control and Prevention, or the CDC, is the leading national public health institute of the United States. They are located in Atlanta, Georgia. The CDC combats emerging diseases and other health risks, including birth defects, West Nile virus, obesity, avian and swine flu, and pandemic flu. And they also deal with E. coli and other enteric outbreaks, and they deal with bioterrorism. So their most recent emergent disease that they're dealing with right now is COVID-19. And if you guys don't know what COVID-19, because they've changed the name for this virus like multiple times, this is the coronavirus. It's been called the coronavirus, COVID-19, novel coronavirus 19, SARS-2, but all of it's the same thing. It's the same virus. Now, China did say that they had a second strain that they actually found, but it was very similar. The two strains are very similar, so that's probably why they're having some reinfection. And we'll kind of go into a little bit about how viruses, invade cells and things like that in a little bit when I talk about viruses themselves. So anybody have any questions about CDC, biosecurity, or anything like that? Because now we're about to talk about what are microorganisms. Okay, so what are microorganisms? Well, first let's talk about microbiology. So microbiology is the branch of biology that focuses on studying microorganisms. So there's different branches of microbiology. There's bacteriology, which is the study of bacteria. There's mycology, which is the study of fungi. There's protozoology, the study of protozoans. There's phycology, which is the study of algae. There's parasitology, which is the study of parasites. And some of those parasites are not microscopic. It could be, even insects and things like ticks and things like that. They fall under that category, but they're able to transmit microorganisms, so that's why they're of concern in microbiology. Then there's immunology, which we talked about a lot last week when I talked about the immune system, which is the study of the immune system. And then there's virology, which is the study of viruses, and then there's nematology, which is the study of nematodes. And nematodes are normally parasitic worms. They fall under that whole order of annelids, but that's a whole family of, it's called nematodes. So bacteria. Sorry. So first, we're really going to focus on bacteria and viruses because these are the main ones that are a concern right now. And I think people are confusing the two. But at later dates, I can actually go through all these other, different branches, because they all have where there's some diseases that fall into those categories caused by those organisms. So we're going to talk about bacteria first. So bacteria are microscopic living organisms, usually one cell, that can be found everywhere. They can be beneficial or pathogenic. They come in different shapes: cocci, spear, which is a spear shape, bacillus, which is a rod shape, spirilla, spirochetes, and then there's an other with like a vibrio shape and things like that. And I'm not sure how well you can see these pictures. So we have the cocci here, we have the bacilli, and then we have the what do you call it? The vibrio and the spirochetes and the spirilla and things like that. Kyra wants to know, the COVID-19, would it be considered a virus or would it be considered a bacteria? It is considered a virus, and I'll talk about what viruses are in a minute. Thanks, Lucy. Yes, it is a virus. Bacteria, they reproduce by binary fission, or what they do is they split themselves. That's how they go about reproducing. They consume. So there's some that are heterotroph. They eat other organisms or they absorb dead organic matter. And there's some that are autotrophic, which means they carry out photosynthesis like plants. So they have chloroplasts and things in them. They are able to carry out photosynthesis. But for the most part, most bacteria are heterotrophs, which means they have to feed on something else to survive. So there's different types of bacteria. There's gram-positive and there's gram-negative. No, COVID-19 is not a bacteria. It's a virus. So it's not a spear. We'll talk about viruses in a second. So when a bacteria is gram-positive or gram-negative, that has a lot to do with how you're going to actually control these organisms. Say if they're pathogenic, and you have to do some type of control measure. They have a cell wall made of peptidoglycan, which is thick on gram-positive and it's very thin on gram-negative. And like I said, this becomes very important when selecting an antibacterial agent. Then there's some bacteria that are aerobic, which means they need oxygen. And there's some that are anaerobic, which do not need oxygen. And that's also important when it comes to dealing with certain bacteria. A lot of the pathogenic ones are actually anaerobic. And so you have to know the environment and things that these bacteria prefer, so that you know how to deal with them, especially if they're in the body and things like that. So viruses, let's see, I thought it was a spear. So viruses, they're actually non-living. They're small infectious agents that replicate only inside the living cells of an organism. Viruses can infect all types of life forms, from animals to plants and to even other microorganisms, including bacteria. Viruses can even be RNA or DNA viruses. What they do is they use a cell, they invade that cell, And what they do is they put their genetic information into that cell, and they use the genetic information for that cell that they invaded, and they actually replicate themselves. And then they cause that cell to rupture and release all the new viruses that were created. But viruses, like I said, they're not living. They are just agents that can contain genetic information that replicate themselves. They don't undergo any type of the biological processes. They don't feed on anything. They can't even replicate outside of their host. So when you hear people saying like they're going to kill a virus on a surface and things, technically it's not even living. It's also not replicating because it's not inside the host. It's just there, and it's waiting to find a suitable host. So that's why they're always saying when you're touching things, you should wash your hands and things, because you can pick up that one virus, and if you're a suitable host for what it needs to, replicate itself, then that's how you become infected. Um, but there's different virus structures, but all viruses have the same basic structure. They have an inner core made of a nucleic acid, and they have a capsid protein coat surrounding the inner core. When you guys are saying it's a sphere, yes, it's kind of a circle. The particular COVID virus is a circle, and it has, the outer, the proteins and things that make it able to attach to the cells and things, but they don't do a type of categorization for the viruses, as they do for like bacteria. Yes, it only replicates once it's inside a suitable host. So if the human, in this case, like the COVID-19, humans are a suitable host. So it will replicate once it attaches itself to the cells, injects its its RNA into the cell, and it replicates itself. Then it causes that cell to life. That's when it can actually, spread and infect more cells. But until that point, if it's just sitting on like a surface, it's not doing anything. It's not alive. It doesn't have anything to do anything with. It has to be inside of a host. So there's different viruses. Like I said, viruses can infect different organisms. So there's some viruses that only infect plants. So humans would never be able to get those viruses. But there's some viruses that can jump species. Some viruses that, affect, an example would be West Nile virus. It can infect birds. So a mosquito can pick up West Nile virus after feeding, and she can bite a human, and that virus is able to live inside of the human because we are now considered a host for that virus as well. And so it's able to, now I wouldn't say live, it was able to go inside a human and actually carry out its replication process. But again, like I said, they're not alive. So there's two different types of viruses. There's envelope viruses and there's non-envelope viruses. Envelope viruses are sensitive to heat and disinfectants. Non-envelope viruses are resistant to heat and many other disinfectants. So the coronavirus that we're dealing with right now, it is an envelope virus. So it's enclosed within a lipid membrane, and it should be sensitive to heat. If it was a non-envelope virus, it would lack a bilayer lipid, so it wouldn't have this outer membrane on it, and it would also be heat resistant. And non-enveloped viruses are usually harder to destroy because they do not have this envelope. Now, saying that, there are some envelope viruses that are hard to, destroy as well, even if you have, the right types of disinfectants and things. Yes, the Aedes aegypti and Aedes albopictus mosquitoes can carry the dengue virus. RNA stands for ribonucleic acid, and DNA stands for deoxyribonucleic acid. So RNA, when you take DNA, you can transcribe it into RNA, and then you take RNA and you can translate that into proteins. But that's a whole another discussion. That's I forget the branch of the molecular genetics. When you're actually taking DNA and you're breaking it down to its smallest form. What do you mean would a coronavirus become like H1N1? H1N1 is a flu virus. Coronavirus is a coronavirus. All right. Since bacteria and viruses are not the same, the measures to control them are not always the same either. COVID-19 is a virus, but many of the methods being used to control it are those targeted for bacteria. So, hold on one second. So when we're talking about bacteria, um, and you're comparing them with viruses, what you need to know is bacteria are self-reproducing, like we talked about. Bacteria are able to grow, feed, and excrete. Bacteria contain various cell units, organelles, cytoplasm, things like that. Bacteria are many times larger than viruses. Bacteria have complex DNA, and bacteria mutate, multiply slower than viruses. Viruses are not self-reproducing. They need host cells to multiply. Viruses insert their DNA or RNA into host cells. Viruses lack any type of metabolic function, so they do not grow, feed, or excrete. Viruses consist only of genetic material and protective coating. Viruses are smaller than bacteria. Viruses have very simple DNA, usually it's RNA, and viruses mutate or multiply much faster than bacteria do. Okay. All right. So antimicrobials. Does anybody have any questions about bacteria or viruses, or even about microbiology? Is COVID-19 a protein-based virus? COVID-19 is an enveloped virus, which we'll talk about a little bit more in a minute as I get into talking about these antimicrobials. They have proteins on them. All viruses do. So I'm not sure what your question is. It's an enveloped virus. So it has that outer membrane that's made out of protein that's protecting it. What's your question, Lucy? So Lucy has this question. If a person dies, someone dies from COVID-19, is the virus still there at the corpse? Yes, the virus will still be there. So anybody handling that body, they will have to take precautions to make sure that the virus does not spread to anyone that's handling that body. I'm not sure of that the infected have to be cremated. I'm not sure how they are dealing with the deceased um, individuals that have died from this particular virus. How long does it take? Okay, so we have another question. How long does it take to push a virus out of the body? That depends on the virus. It also depends on the person that's infected with the virus. There's a lot of factors that go into that. A person's health, as well as what the virus is. There's some viruses that, they can lay dormant in a person for a given period of time, and then they flare up. Something triggers them to flare up. An example with that would be like herpes virus and things like that. Some people, they're going to be constant carriers for the rest of their life of a virus, or an animal could be a constant carrier. So it totally depends on that actual virus. How long? Typical, like when it comes to the flu virus, on average, it takes about 21 days for the body to actually recover after becoming symptomatic, and that requires your body to elicit the immune response for it to fight the virus off, then for your body to go into a healing phase. So it could take about 21 days up to a month before you actually recover from being infected with an influenza virus. With this COVID-19, since it's a novel, which means a new virus, there really isn't a lot of data to explain, like, what's the recovery? Is there going to be any damage because of these individuals getting it that did recover? I've been seeing articles where they said some individuals are going to have lung damage, but they're not explaining which individuals. Are those the ones that had underlying health conditions, or is this just everybody that's had it? I mean, China, they've had record numbers of people recover. They're actually getting their infrastructure and things back up and running again. So it, like I say, For the recovery of a virus, it totally depends on the individual as well as what virus is present, and then also what if there are any antiviral medications and things being used. In this case, there aren't any at this point. That also can, quicken the recovery time. Also, when we talked about last week about the immunity, and I was talking about those anthocyanins, things like those anthocyanins, they show in lab that they were able to keep viruses from actually invading cells, and actually, and then the ones that did invade, they were actually able to keep them from escaping the cell. So once the virus escapes the cell, that's infection, because what they're doing, they're just escaping and they're going and attacking other cells that are nearby, and they're going to do the same thing. They're going to put their DNA, replicate themselves, and expand. So it takes your body quite a bit of time to get that whole attack under control. Once your body gets under control, then that's when the recovery starts. But that could be, like I say, it depends on a lot of different factors. Okay. All right. So antimicrobials. An antimicrobial agent is defined as a natural or synthetic inhibits the microorganisms such as bacteria, fungi, and algae. This control is two basic ways. Either it kills or destroys the microorganism, or it inhibits the growth of microorganisms. So this picture I used last week during the immunity talk. But basically, we have antibiotics or antibacterials that control bacteria. We have antivirals that control viruses. We have antiparasitic agents that control parasites, and we have antifungals that control fungi. So if you ever experience an outbreak, like in this case, we had the COVID-19, there are things that you can do to prevent the spread of that virus, or, if it was a bacteria or whatever microorganism it is. There are modes of microbial control. Sterilization is the process of destroying all living organisms and viruses. A sterile object is one of free of all life forms, including bacterial spores as well as viruses. Midnight Queen says she loves the presentation. It takes me back to biology with Miss Gray in the 90s. Yeah, I mean, all this you should have learned in biology class. If you took anatomy, you should have learned about immunity and things like that. I guess people just never thought they would have to apply it, but today is very relevant. All that knowledge that you might have learned in grade school and in high school. Disinfection. So disinfection is the elimination of microorganisms, but not necessarily endospores. So endospores are made by those gram-positive bacteria, because they have that thick peptidoglycan layer. They can actually make endospores if they're in an environment that is not suitable for them to live, and they can endospore, and then later on, when they are put into an environment where they can actually survive, they will come out of those endospores and will start to divide and reproduce and make more bacteria. So decontamination is the treatment of an object or an inanimate object surface to make it safe to handle. So decontamination, that could be like when you're working in a lab, and say you're in the BSL-4 lab and you're dealing with anthrax, they'll have you go through these showers and they'll spray you down because you'll have these suits on. They'll spray you down, and then you have to take that suit off, and then you have to take those clothes off that you're wearing. You have to go shower and things like that. So that suit, they're actually decontaminating that suit before you actually go out into another environment. Disinfectants is an agent used to disinfect inanimate objects, but generally too toxic to use on the human body. So bleach is an example of a disinfectant. We use bleach to, disinfect a lot of things, but it's recommended that you don't use bleach on your body because it can be corrosive. An antiseptic is an agent that kills or inhibits growth of microbes, but is safe to use on human tissue. A sanitizer is an agent that reduces microbial numbers to a safe level. So there's still going to be microbes present, but they're reduced to a level that, public health deems that it won't be able to cause, an outbreak situation and things like that. Antibiotic is a metabolic product produced by one microorganism that inhibits or kills other microorganisms. So antibiotics used to be synthesized from other living organisms, but now they have synthetic antibiotics as well. Chemotherapeutic synthetic drugs, they can be used therapeutically. Um, there are some cancers that are caused by, like things like viruses and things. So, chemotherapy drugs can be used for that. They also use chemotherapy for malaria as well. Cytals. So if you hear anything that's like bacterial cytal, that means that it will kill microorganisms, or it's a viruses. So a bacterial cytal will kill bacteria. A virucidal will kill viruses and things like that. A static is an agent that is static in action while inhibiting the growth of microorganisms. So there's bacterial statics and things like that they can use, especially in like hospital settings and things like that. All right, so antibacterials, they target bacteria. Bactericidals, they kill bacteria. Examples are antibiotics and cleaning chemicals that specifically target bacteria. So antibacterial soap, that would target bacteria. One factor is if a person is already compromised with a low immune system, like someone with HIV. So like the poet said, one factor is if a person is already compromised with a low immune system, like someone with HIV. Yes, so with COVID-19, that person would fall in a high risk group of individuals, especially if they're actually exhibiting, the AIDS aspect of HIV. They're immunocompromised when they have the AIDS. So they would be a high risk. People that are elderly over the age, I think it's 65, they're considered high risk. People that have asthma, chronic respiratory conditions, heart conditions, people that have things like diabetes and things like that, they are considered high risk. So these are definitely people that should be isolated away, and they should not be, and people that are living with these individuals, they should be very cautious when they're going out and things and interacting with others in the community, because they can bring this virus home and they can infect them and actually cause a lot of problems. All right, Kyra asks, would it be helpful to use salt water to rinse clothing and the body? You don't have to use salt water. Just actually bathing and rinsing off microorganisms is as a benefit. You don't have to use salt water. Salt water will actually dry the skin and things, so you don't want to put too much of that on there. But the actual act of actually washing the microorganism off of your body with just, water and soap. It doesn't even have to be antibacterial soap. As long as you have soap, and you're washing those things off, you're reducing the numbers that are present that could actually probably cause an infection. What alternatives could we use to expose the mutation? What alternatives could we use to expose the mutation bacteria? I hear that citrus pills are able to do so once pulling the virus out of the capsule. I don't understand your question. What do you mean expose the mutation bacteria? I mean, you're not going to be able to see these things unless you have a microscope and things, or you have a test. So exposing it, I'm not understanding. Okay, so back to antibacterial. Again, I said they target bacteria. Bactericidal kills bacteria. Examples are antibiotics, or antibiotic antibiotic soap. Bacterial static, they inhibit bacterial growth. So again, this could be an antibiotic or to be a chemical that you use um, to inhibit growth of bacteria. The efficacy of these can be affected depending on if the bacteria is gram positive or negative, and if the bacteria can produce spores. And again, we talked about that peptidoglycan. Also, there's a lot of bacterial resistance now to antibiotics. Um, and that's a major issue now that we have when it comes to, these super bugs that they call them, that are caused by bacteria. That antibiotic resistance is becoming a huge problem. Um, and so that, it takes about 10, 15, 20 years to develop a new antibiotic, and they haven't even really came up with one yet. Our strongest antibiotic, vancomycin, and then I think there's one more right above vancomycin. There are some bacteria that are becoming resistant to those two. So that's just something to think about as it pertains to bacterial infections. But COVID-19 is not a bacteria, it's a virus. Antivirals, which we're going to talk about now, they actually target viruses. So antiviral drugs inhibit attachment and replication or can destroy viruses in the body. Virucides actively deactivate virus particles outside the body. And again, the efficacy can be affected depending on if the virus is enveloped. Again, COVID-19 is an enveloped virus, so it has that small outer membrane that's supposed to help protect it. All right, so some more definitions because these words have been thrown around a lot too as well. Cleaning is the physical removal of pollutants from an environment. Germs are not killed, but they are denied their food source, or they're just removed from that particular, that particular item. So if you clean something, say you're potting plants and you spill soil all over the place, and the soil could have had microorganisms or something in it. If you clean that soil up, there could still be microorganisms on that surface. So what you would have to do next after you clean it up, you would have to sanitize, which typically claims it's 99% kills of an organism. It's the reduction of the microorganism population or a bacteria. Now, sanitizing, again, it's going to reduce the number of microorganisms that are present, but it's not going to completely get rid of them all. There's still going to be some there. Disinfection is the destruction of microorganisms or 100% kill of a claimed organism. And sterilization is 100% killing and eliminating all organisms on the surface. So when you go to the hospital and you say you're having a surgery, when they said they sterilize like those instruments, they put them in first they clean them, then they sanitize them, and then they put them through an autoclave. And that heat in the autoclave, it actually sterilizes. It kills everything and it destroys spores and everything that's present, so that when that item is used on you and during that surgery, you're not going to be infected with something that could be living on there. Everything should be dead at that point. So any questions about antibacterials or antivirals? All right, so we're going to go in and talk about hand sanitizers now, because I know this has been like the talk of the the entire outbreak. People have been going in, taking hand sanitizer, hoarding it, and things like that. So hand sanitizers is a liquid or gel generally used to decrease infectious agents on the hand. Alcohol-based hand sanitizers are more effective. Normally, alcohol-based may have other chemicals added to them. That could be like lotions and aloe and things like that. To be effective, alcohol levels must be between 60% to 95%. The highest antimicrobial efficacy can be achieved with ethanol between 60 to 85%, isopropanol 60 to 80%, and propanol 60 to 80%. The activity is broad and is immediate, but it's not long lasting. It is recommended that if you're going to use a hand sanitizer, you get between 2.4 to 3 mLs is recommended, what you're supposed to have on your hands. Most of the time, people are not going to have that much on their hands. That little dot that you put in, that's usually not enough. Again, the effects are not long lasting. So once it has evaporated, you know, microorganisms can come back in. Say you start touching things again, it's not going to be still killing them because it has evaporated. Some hand sanitizers are effective against some viruses and bacteria, but at different alcohol concentrations and at different contact time. So contact time is the time it takes for that alcohol to act upon that microorganism to where it will kill it. Or in the virus's case, when it'll denature it and destroy it to where it can't actually, you know, replicate inside of a host. The antimicrobial activity of alcohol can be attributed to their ability to denature and coagulate proteins. The microorganism cells are then lysed and their cellular metabolism is disrupted. Alcohol solutions containing 60 to 95% alcohol are most effective. Notably, higher concentrations are less potent because proteins are not denatured easily in the absence of water. So when you see these, I'm gonna talk about those things I've been seeing on social media. When it says 99%, you're not gonna kill anything with that. And I'll explain why in a second. So here's an example of how 70% ethanol works on a bacterial cell wall. So you have 70% alcohol and 30% water. Water allows the alcohol to permeate or diffuse or move through the cell wall through hydrogen bonding. So if anybody ever took chemistry, you know about hydrogen bonding. The water molecule has 2 hydrogens and 1 oxygen, and alcohol has an OH group at the end that wants to accept an electron. So what it'll do is it'll hydrogen bond with this water, and it'll fulfill that electron that it needs by bonding with this water. So that bonding allows this alcohol to actually go through a cell wall. Water usually can go easily through cell walls on bacteria very easily. Like cells, they need water, so they're going to allow it to come in and out. But there are some regulations that keep the cell wall from keep the cell from swelling. It allows the diffusion of water in, but then water has to be going out. So what happens when this water bonds with this alcohol, this ethanol, it allows that ethanol to actually go into the cell wall and start to break down that cell wall. Once that cell wall is broken down, the cell loses its ability to diffuse water in and out, and what happens is water floods in there, and then it actually lyses or ruptures the cell. So what it produces inside of there is a hypertonic solution. There's more water going in than coming out, and then what happens is it causes that cell to lyse. So that's how these hand sanitizers are supposed to work on things like bacteria and things like that on your hands. But if it's not enough alcohol, so if it's not at least 60%, if it's more water than alcohol, it's not going to work. And if it's more alcohol and not enough water, it's not going to work. So there has to be a happy balance. So Midnight Queen said, I think CH wants a home remedy to testing positive for a virus. There is no home remedy. You would have to, what happens when they're actually testing for a virus, what they do is they take a nasal swab, and then what they do is they use PCR, with polymerase chain reaction. It's a molecular test that they do on it, and they actually find the particular proteins that are found in that COVID-19 RNA, and that's how they determine if a person is positive or negative for it. There's nothing that you can do at home that would say, yes, I have COVID-19 or I have the flu. You would have to have those actual, pieces of equipment to actually do that type of testing. I mean, if you're having symptoms, I would advise you to go to the doctor to get tested. But there's not going to be anything that you can do at home to say, I have this particular virus or I have this particular bacteria. You would have to get those tested in a lab. So anybody have any questions about how the hand sanitizer with the ethanol levels, how it's supposed to work? All right, so using ethanol on viruses. An example would be influenza. A recent study found that alcohol hand sanitizers may not be effective against flu viruses. Reason being, if the virus is surrounded by mucus, which mucus is an innate immune response, especially if a person actually is infected with influenza, they're going to be coughing and their lungs are going to be producing mucus to actually help trap that virus so that it does not further spread to cells and replicate itself. But they said it cannot get to the virus until that mucus dries. So if a person coughs and you know those mucus droplets from them coughing land on the surface and you put your hand on that surface, and instead of you washing your hands, you go and you just get some hand sanitizer and you rub it on your hands, the hand sanitizer is not going to be effective. It has to be, because if that virus is surrounded by that mucus, until that mucus dries out, that hand sanitizer, the alcohol in the hand sanitizer cannot get to the actual virus to actually start breaking down that that membrane, the outer membrane of that enveloped virus. So it won't be effective. And you don't know when a person coughs if they're so the hand sanitizer will not be effective in that manner. Also, the correct amount is not always dispensed from those containers, and it evaporates before it can completely deactivate the virus. They were saying that in our actuality, some of these viruses, it would take about 10 minutes or more before the alcohol could actually be effective at destroying it. Most times when a person puts alcohol, those hand sanitizer on their hands, it's evaporating within about a minute, if 30 seconds to a minute. That's not long enough, they say, a lot of times, for a lot of these viruses to actually, that's not a long enough contact time. Also, the concentration of alcohol plays a key role in the effectiveness. Like I told you, it has to be between 60 and 95%. But certain percentages are more effective against different microorganisms. Where 60 might work on a particular bacteria, it might not work on a virus, or it might not work on another bacteria. 75 might be more effective. So there has to be a lot more research that is done in this area to explain the effectiveness of viruses. And we're going to talk about in a minute about the Purell. So in theory, envelope viruses are easier to deactivate with alcohols, but there are many factors that can affect their effectiveness. Like I say, concentration, contact time, and also the actual virus being exposed to the alcohol all play a role in making them effective substances that can be used to fight a viral infection. So let's talk about Purell. Purell, leading brand of hand sanitizer. So everybody's going out buying Purell, by the droves, like, it's getting taken off the shelves and things. Well, the Food and Drug Administration sent a warning letter to the parent company called Gojo Industries on January 17, 2020. The FDA warns Purell to not claim it can prevent disease. So these are some of the complaints they had when they sent their warning to the makers of Purell. It said, among the claims, the FDA finds problematic because there is no data to back them, that it kills more than 99% of most common germs that can cause illness in a health care setting, including MRSA and VRE, which that's vancomycin-resistant enterococcus. So this is one of those bacteria that's actually resistant to one of our strongest antibiotics we have right now. They also said that it killed. The makers of Purell also said that it kills a resistant type of fungi called Candida auris in lab testing, but it was never tested on a person. So they don't even know if it really will kill it on a person's skin, and there was no real data to show how long it took for it to kill and things like that. They also said it may be effective against viruses such as the Ebola, norovirus, and influenza. According to the FDA, they are not aware of any hand sanitizers that have been tested against Ebola, including Purell. So how did they make that claim if they've never even tested it? They also claim that student absenteeism is reduced by 51% when Purell products are used in conjunction with hygiene curriculums. Where they get that 51%? And, it depends on what's going through the school, that it will be effective or not. Then they also said, the FDA said it is currently not aware of any adequate and well-controlled studies demonstrating that killing or decreasing the number of bacteria or viruses on the skin by a certain magnitude produces a corresponding clinical reduction in infection or disease caused by such bacteria or virus. So basically, they're saying that hand sanitizers, there's no real data to show if they're even effective against viruses or bacteria. These companies are making these things based off, just trying to market a product to you, but in reality, there's no data that shows that this product is even effective at killing these things that they're claiming on their labels. Purell, as well as a lot of other disinfectants, hand sanitizers, and things have not been tested on COVID-19. There's no data on COVID-19. So for everybody going out buying Purell or any other hand sanitizer, there's research at this moment that says that it's going to even kill this particular virus. So I just want you guys to know that. And the FDA has even made this statement that says, I'll read it again. FDA is currently not aware of any adequate or well-controlled studies demonstrating that killing or decreasing the number of bacteria or viruses on the skin by a certain magnitude produces a corresponding clinical reduction in infection or disease. So basically, they're saying, again, the note is you reduce the number of viruses or bacteria in your hand with this hand sanitizer, that you're not going to have infection, or you're not going to get sick, or you're not going to have spread of disease. There's no data that proves either or, that it's effective or it's not effective. So we talked about the hand sanitizer, but we're going to talk about now the FDA and their stance on antibacterial soaps. According to the U.S. Food and Drug Administration, there isn't enough science to show that over-the-counter antibacterial soaps are better at preventing illness than washing hands with plain soap and water. To date, the benefit of using antibacterial hand soap haven't been proved. In addition, the wide use of these products over a long time has raised the question of potential negative effects on your health. They took the triclosan out of soap, antibacterial soap, a few years ago, because triclosan was linked to it was carcinogen. So even if it's antibacterial soap, it's not going to be effective against COVID-19, because COVID-19 is not a bacteria, it is a virus. So just letting you know, these things are not going to be effective. Antibacterial soap is never going to fight a virus, and the hand sanitizer, even the FDA said that it doesn't even, there's no proof that it shows that it reduces infection or disease spread. So this is the FDA, the Food and Drug Administration. This is our government agency. They're the ones that are responsible for, approving these products and things like that. They're saying that there's nothing that proves that, number one, antibacterial soap is even effective against bacteria, or that the hand sanitizers are effective against, stopping the spread of disease. So what do I suggest if not Purell? I'm saying that hand sanitizer is not, there is nothing I suggest other than you wash your hands to get the bacteria off of your hands or the viruses off your hands. But just know that these products that are for sale, they're not holding up to the claim that they're making. There's no data or research behind them to even prove that they are able to even do these things. So, should you make your own hand sanitizer? I would advise against it, since there's no proof or data that shows that hand sanitizer is effective against COVID-19. There is no hand sanitizer out there that has been tested to say, yes, it will kill this virus and it'll kill it in 30 seconds. There's no data. There's no research. There's no lab. There's nothing right now that proves this or not. So you going home and making a hand sanitizer, it's not going to prove it either. You won't know if it's killing it or not. I mean, you don't even know if you have it or not. So when you see those memes circulating, they're not even giving correct information as far as the formulation. And this particular picture I have right here, it said to use 99% isopropyl alcohol. Now I just told you that for even a hand sanitizer to be effective against bacteria, to kill it, it had to be between 60 and 95%. 99%, there's no water in there. It's not enough water to actually allow water to go into that cell and lyse it. So it's going to be ineffective if you use 99% alcohol. Again, no one knows if it's even effective anyway against COVID-19. And no one knows the contact time that needs to be had. No one knows the alcohol percentage that needs to be used. The effective of alcohol and alcohol percentages has not been determined for novel coronaviruses or the contact time. So it might be that for a hand sanitizer to be effective against COVID-19, it has to stay on the hands for at least 2 minutes. Well, if you're using 99% alcohol, that's going to evaporate as soon as you take it out the bottle. So, it might evaporate in like 10 seconds. If you're using the 70%, it might stay on your hands a little longer, but is that an effective percentage? No one knows because there's no data to prove that otherwise. So I'm just telling you guys that don't put so much faith into these products that they're marketing to you, and you guys are going out to the store and fighting over. There's no data to even prove that these things are going to even be effective. So what you should do is wash your hands for 20 seconds, but know that you can still get infected via aerosolized droplets after someone coughs or sneezes, or you touch an infected surface. So you can wash your hands all day, but if somebody in your house is coughing and sneezing, that virus is airborne and you can just breathe it in. You don't ever have to even touch your hands. It also can go in through the eye, the membranes in the eye. So know that as well. So the best thing is you can do in your household is you can create a biosecurity plan for your home. You can say, like when I talked about what biosecurity was, like on a farm, you're controlling the flow of traffic and things. You're controlling what comes in, what goes out. And if you have infected people, you're making sure they're staying home, they're being treated, or they're being isolated and quarantined away from everybody else and things like that. You can also use surface disinfectants preliminarily approved for COVID-19. Again, these products recommended by the EPA, CDC, and FDA are presumed to work, but there again is no data that there's no data that says that this particular product has been tested and proven to kill, or not actually kill, but denature this virus. You can work on maintaining your overall health through diet, exercise, and limit your exposure to sick people. And also know that toilet paper is not an antiviral or a viricide, so you don't have to go and buy and hoard, rolls and rolls of toilet paper. But I just want you guys to understand that, they're marketing products to you that they don't really know if they work or not. They are just under the assumption it will work. I mean, even when they had the SARS, there's not a lot of data that says these products were effective against these things. They're trying to base it off SARS and off of MERS-CoV, but there's not a lot of research that's proved that these things were even effective against those viruses. So I don't want you guys to have this false reality like, oh, I got my hand sanitizer and I got my antibacterial soap, so I'm good. No, you're not. Because again, there's no data, there's no research. They're just assuming because it's an enveloped virus that, oh, this might be effective, but they don't even know at what level and what contact time and all these other things. So the best disinfectant to use right now is probably going to be bleach. And I know that's very, caustic and things, but that will destroy most things. There's some other things, and I put the list here, and I'm going to actually put it on the school website as well. You can go there and you can look at the other cleaning materials that they use for the environment. Now, for your body, again, it's simply washing your hands a little bit more often than you normally do. Being conscious of where you put your hands, especially if you're interacting with people outside of your home, just remembering, trying not to touch your face, your eyes, your mouth, things like that. Um, and maintaining your overall health through diet and exercise. That would be great. But if a person is immunocompromised, they need to stay away. They need to stay isolated for a while. Because they can, they are the ones that are being most affected by this. But there's no magical product out there that's gonna kill this. I mean, even I see people saying Bronner soap. Yes, you use the soap to take a shower. Showering and bathing is also important. Just because you wash your hands, your body is your first line of defense against microorganisms. So your body all day, your skin is your first line of defense. So all day it's interacting with microorganisms, good and bad. So if you're daily showering will help remove and reduce those numbers of bacteria, viruses, and fungi, and all types of things that your skin encounters. But there's no magic soap to or a product that says yes, it's going to kill COVID-19 and I'm scot free. No, there's nothing out there that says that. Nothing. So should I dilute the bleach? Yes, I'll put that formulation that they recommend that you use. I think it's like I can't remember percentage. I'm not going to even say a number. But I will put that on the school website. But in conclusion, before I show the school website information, I just want to say biosecurity is important at controlling pathogens. Bacteria and viruses are not the same thing. Antibiotics may or may not be effective against viruses. More research is needed. So anybody have any questions? So all my YouTube lives, they are on my school website. I thought I had the link on here. I'll put it in the comments. So every time I do one of these lives, I make a folder and I put all the scientific journals and things that I use to make these presentations in there. I'll put links and things that I think are relevant for you guys to go and visit. So I'm going to put that list of cleaning products that they presume will work against COVID-19. And anything else I feel that is pertinent that you guys need to know. And I'll put the bleach solution, the formula they recommend that you use on there. Building up your immunity is the best way to avoid being sick. So Kyra said, building up your immunity is the best way to avoid being sick. Just keeping your body healthy. The only way you build immunity is that you have to be exposed to a pathogen. So the only way you're going to build up immunity to COVID-19 is to actually be exposed to the virus, and your body builds up immunity against that. But not being exposed, you won't ever get sick with it. So just being conscious of who you're around and things like that. Also, eating things like when I talked about the anthocyanins last week, eating things that can help your body fight off an infection once it invades. That's what you need to be doing. Also, not smoking, not drinking, using drugs. There were a lot of different factors that affected the immunity that I talked about last week. And if you want to watch that particular YouTube live, it's on my my page on my YouTube channel. You can watch that one as well. So Kay Mondale, any suggestions for healthcare workers? Yes, it depends on your level of healthcare work. If you have direct patient contact, make sure you're wearing your PPE, your proper equipment that you're supposed to be wearing. Make sure you're washing your hands. Just know that don't just rely on that hand sanitizer. Wash your hands. But also, if you have to use hand sanitizer, maybe wearing gloves and things would be ideal for you. Also, making sure that that you're isolating patients, if you're supposed to be isolating certain patients away from other, sick individuals, so they're not spreading the virus or whatever. Because in a hospital, you're encountering everything. It's not just COVID-19. We must remember flu is still out there. There's still common colds that are caused by other coronaviruses. There's pertussis, which is whooping cough, that's going around. those numbers have been increasing over the last 10 years astronomically. Then there's people with asthma and all types of other things. So just be mindful of that when you're when you're in the hospitals or you're working in the doctor's offices, making sure that you're following their protocols. All right, so anybody else have any questions? All right, so if you need to contact me, here's my information. You can go to the school website here. It's www.kiwiproducefarm.com/school. Let's see if I can get that to pull up on here. See if I can pull that up so you guys can see what it looks like, so I can show you where you can go to actually access that information. All right, so on the school website, if you scroll all the way down to the bottom, there's some other classes on here that you can register for. You can take these classes. Some of them are recorded, some of them will be live. I have another class coming up on the 21st. But here at the bottom, it's a YouTube live discussion. So you click on the link here. You don't have to even register. You can come right in here and you can access all of the other YouTube lives I've done. And so this was the one from last week, not that one. This one right here, where I talked about immunity. Then I talked about troubleshooting some seeds and stuff. So I'm going to have another topic this Sunday. I also have two COVID-19 isolation solution webinars coming up, one on Wednesday and one on Thursday. We're going to have guest speakers. We'll have one guy talking about how to prep. He's a disaster preparedness expert. And so he's going to talk about how to prepare for situations such as this, so people aren't just going out buying, toilet paper. They're actually going out buying things that they can use that will be of benefit to them. And then we're going to speak with Kyra Barr. She's actually here in the chat. She's a homeschooling parent, and she's going to talk about homeschooling for the next 3 to 8 weeks or even longer. It's going to require the parents now to actually be their educators and their teachers. So she's going to talk about that on Thursday. Erin's going to talk about prepping on Wednesday. And then if I find some other people to talk about some other subjects, I'll schedule those as well. If you want to watch those, they're on the links are on my YouTube channel, which is youtube.com/Urban Farm Sister. And so, like I said, we'll be talking to them this week about that. Then I have classes and things coming up. So if you guys are interested, you can always visit the website and find out what's going on. I also post on social media and things like that as well. All right. Do you recommend we keep up with? Oh, you're welcome, Kyra. So website. All right. So any other questions before I get on out of here? These are supposed to be a half an hour long, but I knew this was going to go over because there was a lot of information to cover. The one on Wednesday and Thursday, they will both be an hour long, and then I'll have another one on Sunday. I'm not sure what the topic's going to be yet, but it'll hopefully stay at the half an hour. If not, it's okay if it goes over an hour. But no other questions, I will be signing off. And thank you guys for attending this YouTube live. And like I said, if you have any questions, you can always email me, or you can send me messages on all my social media. I'm on Facebook, Twitter, and Instagram, as well as YouTube. All right. Thank you, guys. Have a good evening.